Today, let's talk about one of those fundamental ideas that makes our modern internet even possible. It's called switching, and it's this invisible process that's managing a massive global flood of data every single second.
Have you ever really stopped to wonder how that one email you send or a photo you post finds its way from your phone through this network of billions of other devices and lands in exactly the right place? It really does feel a bit like magic, but it's actually a super elegant solution to a massive traffic problem.
It really just all comes down to managing traffic. At any given moment, millions, maybe billions of us are sending and receiving information at the exact same time. So how does the whole system handle that without just collapsing into one giant digital traffic jam?
To really get our heads around this, let's use a simple analogy. Just picture two different kinds of restaurants.
Okay, so on the one hand, we've got a reservation restaurant. You know the type. You have to call ahead and book a specific table in advance. And on the other hand, there's a walk-in restaurant where you just show up and grab the first table that's free. Believe it or not, these two models perfectly illustrate the two basic ways networks handle all of our data.
So let's start with that first one, the reservation restaurant. In the world of computer networks, this method is called circuit switching.
The process here is actually pretty straightforward. Step 1, you reserve a completely dedicated path from your device all the way to the destination. It's just like calling that restaurant to book a table. Step 2, once that path is yours and only yours, you send all of your information down that one single unbroken line. And then step 3, when you're all done, you release the path so someone else can use it. So the key word here is circuit. It's a dedicated connection where all the resources, the bandwidth, the speed, are reserved just for you for the whole time you're connected. It is exactly like that reserved table. Whether you're eating, talking, or just sitting there silently, that table is yours and nobody else can touch it. The classic example of this is an old-school telephone call. When you used to dial a number on a landline, the network would literally establish a physical, dedicated circuit between you and the person on the other end. That line was exclusively yours until one of you hung up the phone.
But you can probably see the downside here, right? What happens if you and your friend both stop talking for a minute? The circuit is still open, the line is still dedicated to you, but no information is actually being sent. All of those reserved resources are just wasted. It's like an empty, reserved table in a super busy restaurant that has a long line out the door. Not very efficient.
Okay, so now let's move on to our second model, the walk-in restaurant. This on-demand method is called packet switching, and this is the powerful system that makes the modern internet work.
See, instead of reserving an entire path from start to finish, packet switching does something way more dynamic. First, your bigger message, an email, a photo, a video clip, whatever, gets broken down into lots of small, manageable chunks. And these little chunks are called packets. A great way to think about them is like tiny digital envelopes. Each one has a little piece of your data inside, but crucially, it also has the destination address stamped right on it, telling the network exactly where it needs to go. Now, this is the really clever part. Each one of those packets is sent out into the network all on its own. They don't have to follow a single reserved path. They just find their own way, hopping from one router to the next, taking whatever route is open at that moment. It's just like individual diners at that busy walk-in restaurant, all finding any empty seat they can instead of waiting for one specific table. And then, once all these little packets finally arrive where they're going, and hey, they might even get there out of order if they took different routes, they're all quickly put back together into the original complete message. That address on each packet lets the receiving computer know exactly how to reassemble the puzzle.
So let's just put these side by side for a second. With circuit switching, our reservation model, resources get locked down ahead of time, which, as we saw, can be pretty wasteful. But with packet switching, our walk-in model, resources are used on demand. This is so much more efficient because everything is constantly being shared. And that's why circuit switching is great for old voice calls, but packet switching is just perfectly designed for the internet.
Okay, so this all leads us to the big so what? How does this explain why the internet can handle so much data from so many of us all at once? Well, the answer is that the internet is built entirely on this principle of packet switching. This walk-in restaurant model is what allows for this incredible sharing of network resources. It's the reason millions of us can be online at the same time. It's why network costs are lower, and it's how you can stream a movie, check your email, and browse a website all at once without having to reserve 3 separate lines. It's all just happening over the same shared space.
There's this quote that just sums it up perfectly.
Packet switching allocates link use on demand. Circuit switching pre-allocates use regardless of demand. It really is that simple but profound difference between a system that serves you when you need it and one that makes you hold a spot just in case.
So the next time you're online, doesn't matter if you're sending a quick text or watching a whole movie,
Just take a moment and picture your data broken up into all these tiny packets, joining a bustling, incredibly efficient worldwide walk-in restaurant, with each little piece finding its own unique path to get where it's going, sharing the space with billions of others.